Hey friends, a very good evening and thank you for joining in. Could you please confirm in the chat window if I'm audible and visible clearly? We will get started with the live session itself at 7:02 or 7:03. So could you just confirm if everything is working as expected? Okay. Okay, I can see myself on the phone, so I don't think, okay. So everything is looking good, good. Hey, good evening, folks. Since we joined a little early, I'm happy to take any general questions. As usual, we will start the live session itself at 7:02 or 7:03. We'll solve a bunch of interesting problems. And then we will have a general Q&A again at the end, right? So feel free to ask me general questions. I'll try to answer as best as I can. Hey, good evening, folks. Thank you. Okay, so very nice question from Pranav that GATE 2006 questions are very tough. Is it okay? Because if they're troubling you, yes. I think it is one of the hardest GATE papers because I wrote that GATE examination in both 2006 and 2007. 2007 was a trivially easy paper. 2006 was a fairly hard paper. I wrote both of them. So yes, if you're struggling with 2006, that's okay. Just remember that the topper in 2006, they were my 1-year seniors at IISc. If I'm not wrong, if I recollect correctly, the question paper was for 150 marks and the topper I think got about 68 or 70 marks. It's a fairly hard paper. So if you're struggling with some of those questions, it's okay. Don't worry too much about it. That's more like an outlier, but it is always, again, remember, your competition is with people who are very similar to you, right? So don't worry too much about it. Because if a question paper is hard for you and if you're prepared well, it's also hard for others. So this is from Manish who says, I've joined IIT Kanpur. Any advice for getting good placements? Manish, 2-3 things. One is try and become very, very good at data structures, algorithms, and the standard competitive programming thing, because for at most IITs, that's like the bare minimum that is expected. On top of it, in your course projects, whatever area you pick up, whether it's distributed systems, machine learning, or whatever area you pick up, try to do some good real world projects and write technical blogs about it. That will help you stand out from the regular crowd at IITs who are just good programmers. So you also want to showcase that in addition to being good at data structures, algorithms, programming, you also have solved some interesting real world problems and you have some nice blogs or technical blogs or GitHub profile to showcase that. I think that's what I would recommend somebody who's just starting their MTech right now. Can you cover solving problems with Catalan numbers? Aniket, we will surely do that when we do some discrete math. So that's where we cover more of it in detail. We'll surely cover that because I think after we finish data structures algorithms, I think we have subjects like discrete math coming up. So we will surely cover that without doubt. And you're saying you got 55% in practice tests. That's good. I mean, that's very good. I mean, you're on the right track. Just make sure to debug your mistakes and keep increasing from the 55% towards the 70%. So Yash says, how much time does it take for a complete beginner to complete data structures and algorithms? So roughly, if I have to put it, if you're doing it for the very first time, if you know basic programming, I mean basic functions, loops, right, basic stuff, if you already know it, arrays and things like that, you can comfortably finish DSA in a max of 4 weeks. You can comfortably do the basics in about, the basic concepts, you can do it in 4 weeks. Again, for the GATE preparation, that's what I mean. So Shavik says, please make difficult questions in this test series. Again, Shavik, we always try to look at the previous years and use that as a guideline when we create questions for the test series. We certainly have a few medium level questions, some tricky also. There is no point in doing very hard questions because you'll never encounter them, or there is a very low probability of encountering them in the GATE examination. And just, I mean, it's very easy for us to give hard questions because we just have to go to world-class textbook, take the hardest problems and modify them to GATE standards. But that's not helpful because it will demotivate some students, and that's often not needed for GATE if your objective is GATE prep. So we will try and balance those things out. So somebody says, so IIT Kharagpur previous year questions not easy, some questions are hard. Again, I think there is a misconception that all the questions for a GATE examination come from the institute that is coordinating the GATE exam that year. That's not true. All the participating institutions, all the IITs, NITs, and also IISc, they put in the questions, right? Everybody collaborates to create the final question paper or papers. The organizing institute is one of the is the central nodal body that finalizes the format and all the other stuff. But don't just think that, okay, this question paper is hard because this was the year that Kharagpur or Bombay conducted it. That's not always true, because we looked at the historical data of the same. Cool. So Pratik says, what is the level of GATE 2021 set 2 paper? I would call it medium with more tricky questions. That's it. It's not actually hard by even by GATE standards. It is certainly trickier. If you observe the last 2 to 3 years of GATE question papers, what we are seeing here is there are more tricky questions rather than hard questions. Okay, that's a very important thing. That's why even in some of these live sessions, we are focusing more on trickier questions where students commit mistakes. How is IIT Hyderabad MTech CSC? I got admitted there, says Amit. It's a very nice institute. Again, I'm very happy that IIT Hyderabad, even though it's a new IIT, it's picked up very well, primarily because of its students, also to some extent faculty and the curriculum. And they're also in a major tech hub, which is Hyderabad, right? And also very close to Bangalore, which is the other major tech hub. So, I mean, I've had even colleagues, the early batches of IIT Hyderabad, I've worked with some of them, very good candidates. So I think it's a great place. Just make sure you excel during your MTech, stand out from the crowd, be the top 5% of your class, and then there is no difference between going to IIT Hyderabad or any other IIT or IISc. So this is from one of the students who says, where can I solve more TOC problems after I complete practice questions? So if you're a course enrolled students, because you're talking about practice questions, you have the tests, the previous year test series and this year test series, where for TOC itself, you have topic tests, subject tests. So once you finish TOC, all the practice problems, you can use these problems. And you can also solve previous year questions from TOC. I think that will be like sufficiently good practice for any given subject. Actually, it's more than sufficient in most cases. Okay. Can one shift to product management after MTech in CS? This is from Pradyumn. I've seen a lot of engineers who move into program management and also product management, right? So I've seen a lot of engineers do that. So you might join, let's say after your MTech, you might join as a software engineer, but you can easily, or even a data scientist, and move into product management if that's something that you prefer to have in the long-term career. Again, most senior engineers end up doing some amount of product and program management as part of their regular work anyways. So somebody says, I'm not reading the textbook, will I get low score in GATE? Again, the way we have created most of our content is we've taken standard textbooks for every subject, at least 2 to 3, typically 3 to 4 textbooks, and we have condensed all of that material for the GATE examination, very specific to the GATE examination. So if you don't have time, that's okay, you can skip it. We've had a lot of toppers even in the previous years who, due to constraints of time, couldn't read a standard textbook. That's okay. What is important is understand the concepts, solve practice problems, solve as many problems as possible. I think if you do that, and if you don't have time and you're skipping textbooks, that's okay. That's not a problem at all. So this is from Brajandan, who says, what is the scenario of getting into PSUs after GATE CSC? We've had some students who got into PSUs, but the number is fairly low as compared to, let's say, mechanical engineering or electrical engineering, even communications engineers, because the number of institutions that hire is very few. You have a few people who are hired by, let's say, Bob Atomic Research Center, few by NIC, right? Again, some of the other PSUs also hire few here and there, but the number of people who are eventually hired is significantly low as compared to let's say electrical or mechanical engineers. So it's still significantly low. But of course, if you're interested, because most CS gate toppers are not very interested in PSUs, most of them, I'm not saying all, most of them. So even if you get a slightly larger rank, you might stand a pretty good chance in getting into PSUs. Yeah, we're experimenting with some new camera system and lighting system, so let's see how this works. Okay, it's 7:06. I completely forgot. I'm sorry. So let's get started with the questions. I promise you, we will come back. One second. So we will come back to the general Q&A at the end of this session. So let's solve the questions. Let's solve about 5 interesting questions today. And then as usual, we will have a general Q&A at the end, right? So today's topics are AVL trees, hashing, collision, graphs, and a little bit of graph traversals. Let's start. Cool. So this is the 5th session. I think we have a total of 7 sessions. The schedule is also pinned by our team at the top, so you can check it out. So all of data structures algorithms will be publicly available. I think we'll finish it by next week. Okay, so let's get started. Here is the first question. It's a numerical answer type. Please be careful, don't make silly mistakes. This question is a slight remodification of a question from GATE 2016. Again, everybody who has put in their answers, please rethink about them. I see a wide set of answers. So please revisit your answers. I see a lot of mistakes also, obviously. Okay, please think about this carefully. I've seen a lot of people making silly mistakes here, especially those who are in a hurry to give an answer. Take time, think through this. By GATE standards, this would be considered as a medium problem. But if you ask me, it's actually a easy problem if you know the concept clearly. Again, draw diagrams and visualize things. That's always a good strategy. I only see a few of you who got the answer correctly. Most of you haven't. So please revisit your answers. Take time, it's okay. There was a slightly simpler problem than this in GATE 2016. But similar type. Okay, I don't see any more answers. I'll wait for a few more seconds for people to correct their answers and then I'll go into the solution. This does not require any complex combinatorics or anything. It's a very simple. You just need to know what is a topological ordering and you need like 10th, 11th class math. Okay, so let's go into it, right? So you want a topological ordering, right? So which means 1 should come before 2, 2 should come before 4, 4 should come before 6, 6 should come before 8. Similarly, 1 should come before 3, 3 before 5, 5 before 7, 7 before 8. And since 2 and 3 don't have any edge, they can come in any order, right? So if you observe, 1 has to be, so in any topological sort, right? So if you see this, the first element has to be 1. The last element has to be 8. So these two are fixed. Now you have 6 more locations in between. Now within these 6 locations, you need to have 2, 4, 6 in the same order. You can have 2 here, 4 here, 6 here, anywhere. But 2 should come before 4, 4 should be there before 6 because that's a topological sorted order. Similarly, 3, 5, 7 can be placed anywhere except that 3 should always be there before 5, 5 should always be there before 7. Now if you think logically, right, there are literally 6 positions here. Okay, let's see how to solve this. This is actually simple if you think about it. So you have 6 positions here. This position is fixed, this position is fixed. There is only one way to place 1 and 8. In the remaining 6 positions, let's assume I pick 3 positions randomly. Let's assume I pick this position, I pick this position and this position. In how many ways can I pick 3 positions out of these 6 positions? 6 choose 3. Right? There are 6 choose 3 ways of picking 3 positions from these 6 positions. In these positions, let's assume I place 2, 4 and 6. Right? Which means I can place 2, 4, 6 in 6 choose 3 ways. Now once I have placed 2, 4, 6, now what am I left with? I'm left with 3, 5, 7. Now if you observe, I have to place 3 here. I have to place 5 here. I have to place 7 here because 3 has to come before 5, 5 has to come before 7. So which means once I place my 2, 4, 6, I'm left with only one way in which I can place my 3, 5, 7. So the answer is nothing but 6 choose 3. And what is 6 choose 3? 6 factorial by 3 factorial into 3 factorial, which is 6 into 5 into 4 by 3 factorial is 6. So this would be 20. So the answer here is 20. That's it. Very simple. Again, this is not some fancy combinatorics, right? You have 6 positions. The fact that you have to think of is the position of 1 is fixed. The position of 8 is fixed. And the relative positions of 2, 4, 6 is fixed. The relative ordering of 3, 5, 7 are fixed because of topological sorting. Which means of the 6 positions, I have to pick 3 positions, place 2, 4, 6, and then in the remaining positions, there is only one way for me to place 3, 5, 7. So the total number of ways that I have here is literally 20. Very simple question. Again, by gate standards, this might be considered a medium problem. But I mean, if you ask me, if you know what is topological ordering, and if you can do this simple combinatorics, that's it, right? Again, somebody is asking, why are you taking 2, 4, 6? Why not 3, 5, 7? Either way is all right, right? Suppose, imagine if I first place 3, 5, 7. In how many ways can I place 3, 5, 7? 6 choose 3 ways. Once I place 3, 5, 7, my 2, 4, 6 can only be placed in one possible way because there are only 3 more blanks left and this ordering is fixed, right? Simple logic. Again, somebody is saying, hey, why can't I, again, remember, in the 6 choose 3 ways, remember, in the 6 choose 3 or 6 see 3 ways, 2, 4, 6 will be here. In another ordering, 2, 4, 6 also will be here. Don't forget about how we are counting, right? This is a fair, again, actually to be honest, if you know the basic concepts of topological ordering, this is a simple aptitude problem. Again, most gate questions are aptitude problems plus some core CS concept. That's it, okay. Cool. So again, a very similar question to this was there in GATE 2016, except that you didn't have these 2 nodes. It was a much smaller graph and you can easily enumerate that graph, right? So if you did not have 4 and 5, you just had 1, 2, 3, 2 to 6, 3 to 7 and 6 to 8 and 7 to 8. That is much easier to enumerate. This question we made it slightly trickier because enumeration of all the 20 possibilities becomes much more harder here. Okay, but a similar question. Cool. Okay, let's go to the second question now. So here is the second question. This is an MSQ. This is an MSQ, so please go through each of the options carefully. Please don't miss out on that. Most of the questions in GATE from graph traversals tend to be fairly simple. So this is an easy question, but typically a 2-mark question because you have to go through each of the 4 options. Again, please be careful here. It's very easy to make silly mistakes. I see literally I think most options are different from one another. So please revisit your answers. Don't be in a hurry. I often see that people who are in a hurry who answer fast, like the first 10 answers, the probability of seeing a wrong answer is significantly higher than people who take a few minutes and answer it carefully. This is an MSQ, so multiple options can be correct. This is an easy question, folks. I see a pretty good number of you getting it wrong, which is unfortunate. You don't get partial marks if you've chosen a subset of answers to be correct. You either get full marks or no marks in MSQs. There is no negative marking, obviously. You don't get partial marks. I hope some of you correct your answers before we go into the solution. This is easy. This is very common type of traversal based question in GATE also. Very common type. We will surely answer general questions at the end. In the meantime, let's solve the questions because that's what most students are here for. I promise you I'll answer your questions. I'll wait for a few more seconds and go into the solution itself. This is not even tricky. This is, I thought at least, I think this is easy by GATE standards. It's not, maybe a little tricky, very little tricky, if I have to say that. I don't think it is. I'm very surprised that many of you are getting a wrong answer. I'm very, very surprised, to be honest with you. Okay, so let's solve it. Okay, so you're given this graph. Okay, you have to do a BFS traversal. It's undirected. So, okay, you can start with any node, right? So let's assume we start with A, right? If you start with A, what are all the neighbors of A? G, C, B, D, and you can touch each of these points in any order. There is no one fixed order, right? So the order that is given here is A to G, A to C, right? Again, I just try to draw this traversal tree itself. Again, this is one way I visualize traversal trees. Okay, this is like your BFS traversal tree, right? From A, we go to G, perfect. So this edge is covered. Then A to C, this edge is covered. Then A to B, okay. So this edge is also covered. Then A to B is done. Then A to D, okay. So this is also covered. Till here, I don't see any errors. So A till here, I don't see any errors. Next, what is coming here? Next, it's saying F. So then what happens? Then you go to the first G. Look at all the neighbors of G. G has C as a neighbor, which you have already covered, right? Which you have already traversed, right? So G has another neighbor, which is F. So from G to F makes complete sense. Then after G is processed, we are doing breadth first, right? So then you go to C. Now if you go to C, B is already covered, F is already covered, E is not yet printed. So because there is this edge C to E. So this order A, G, C, B, D, A, G, C, B, D, from G to F, C to E. This is like your breadth first traversal, right? I mean, this is a valid breadth first traversal. So A is surely one of the right options, no doubt about it. So A is right. So let's go to B now. Again, this simple traversal tree is a very useful technique to think of. This time we are starting with G, right? So from G, look at all the edges that we have, G to C, right? So we're starting with C, perfectly all right. Then F, okay, cool, no problem. Till now everything is going good because there is an edge GF. Then you have A, so G to A, cool. This is also working out well. Then B, so from G, so all the edges are done now. From G, you only have 3 edges, right? F, C, and A, all of them are covered. Now you start with C, right? Now what do you have? You have B here. From C, do you have an edge to B? Yes, so you printed B. So nothing wrong there. Then from C, you also have this edge to E, and E is not yet printed. F is already printed. From C, you have an edge to A. A is already traversed. So CE, right? So CE. This is also perfectly valid. Then, okay, nothing else, right? From C, you already traversed A, B, E, F, G. All of them are traversed. Then comes F. From F, if you see, E is already traversed, only D is left, right? Of course, G is also traversed. So you take this. So this is also perfectly valid. B is also valid. Again, this is my breadth first traversal tree. So I start from here, first this, then this, then this, then this, then this, then this. This is just my breadth first traversal tree. Simple way of thinking about it. Now let's go to option C. Again, this is all about drawing these breadth first trees carefully. That's it. Okay, now we are starting with B. So let's start with B. So this is our B, right? So from B, it's saying A. Cool, perfectly valid. B, A. Then you have D. From B, okay, you have an edge to D also. Perfectly valid. Then you have C. B to C is also there. Perfect. So C is also valid. Then you have B to E. Cool. Very good. B to E. B has a degree of 4. So all 4 are covered now. Okay. Then we start with A. From A, what do we have? From A, okay, so E is also done, right? From A, okay, you have an edge to G. Perfect. So you have an edge to G. Where else do you have edges? C is already taken care of. D is already taken care of. Right? Then go to D. From D, A is already traversed, B is already traversed, E is already traversed, only F is left. Right? So perfect. So this C is also correct option. So A is correct, B is correct, C is correct. Now let's go to D. Okay, you're starting with D first. Okay, so you have D. From D, where all can you go? A is there. Perfect, valid. D has a degree of 4, right? So then it says B. Very good. So B is also taken care of. Then you have E. Perfect. E is also taken care of. Right? Then you have C. Here is a problem, no? How can you have C here? C cannot be there, no? Look at this. C is not directly connected to D, and you still have D to F. This should have been F here, not C. right? When you're starting your breadth first search from D, what are all the vertices? You have A, you have B, you have E, and you have F. F is not yet printed. How can you print C directly? So D is the incorrect option. A, B, C are the correct options. Very simple. Again, you can also think about it from the code implementation of BFS, but the simplest way to think of BFS is to draw these BFS trees, right? The actual traversal tree itself. Very simple question. That's why I said this is a fairly simple, straightforward question. Again, somebody says I've done DFS. That's a major silly mistake, and you have to make a note of it. Okay, that's it. It's as simple as that. That's why I said this is 2 marks, but easy. If you know how BFS works, it's straightforward. Cool. Okay, here comes a very interesting question. Yes, BFS is like level by level. Yes, that's what it is exactly. Anyway, let's tackle this question. Take time, think about this carefully. This might be a little time taking. Please feel free to use a calculator as you see fit. This question will require a calculator. Don't be in a hurry to answer this question. This is not a trivial question. This is a medium tricky question. Typically, you can think of this as a 2 marks question. This is a question in the intersection of hash functions, little bit of probability. Not too much probability, but basic stuff. High school probability, like 10th, 11th class probability. I don't know if this is a previous year gate question, but I've seen questions similar to this in the probability and aptitude sections. Similar concept question in probability and aptitude, but this is taking that concept, mixing it with hash functions, because hashing is by design probabilistic, and putting the two concepts together. Nice. Some of you discovered the problem type here. Yes. In classical probability, this is called as birthday paradox problem. Very nice problem. We have just taken that concept and problem type and mixed it with hash functions to make it more interesting and slightly trickier. Humans are very, very bad to think when there is an exponentiation. Like, we don't understand the concept of compounding very well. Somebody is asking, is linear probing applied here? You don't need that here. Don't worry about linear probing here. I mean, that will make the problem more complex, but just ignore that for now. Let's assume that's not a major issue. It's a very nice, birthday paradox is a very interesting thing. Again, don't go by formulae. Try and think from first principles. It's actually easy if you think from first principles. I wouldn't call it. If you know birthday paradox, then this is easy. Otherwise, it's not. Okay. I've not seen many correct answers till now. Okay, take some more time. I'm just writing that this is a type of birthday paradox problem. And we humans are very bad with exponents. Wherever there is exponents, I think we should trust the math and not human intuition. I think some of you are saying D, right? So those of you who think D is the answer, can you tell me what is the right answer? What is the right numerical value? Because I see a couple of you putting in D as the answer. Again, we'll surely solve more problems related to birthday paradox when we solve probability questions. Okay, so I think one or two of you have said D, so I'm looking for what could be their right answer, but I'm not seeing it here. Okay, somebody's saying they got D as the answer with 10. Okay. Okay, so anyway, in the interest of, okay, let's wait for a couple of minutes. Anyways, some people are trying to still tackle it. Okay, so let's solve it step by step, right? I think almost everyone who has put in an answer has got a wrong answer. Okay, let me explain why. This is, again, I agree with you that this is medium to hard by gate standards. Okay, if we have a uniform hash function, which means it's going to uniformly distribute all the keys, right? And the output values lie between 1 to 100 for any input. What is the minimum number of keys that must be present so the probability of collision exceeds 50%? So let's write down from first principles. Always think from first principles. Probability that two keys basically means one pair of keys, right? Probability that any two random keys, right? Because you're doing uniform hashing, it's all randomized. Probability that two keys are one pair collide. What is the probability? Right? If your keys are random, and I mean that's by definition a uniform hash function, right? The probability is 1 by 100 or 0.01, right? Because all the values lie between 1 to 100, right? If you're given two random keys, what is the probability that they will collide? 0.01, which means, in other words, what is the probability that two keys, or in other words, one pair, don't collide? Okay, don't collide. Okay, what is this probability? This probability is 0.99. Always work from first principles. Now imagine if you have n keys. Okay, with n keys, how many pairs are possible? Because any pair can collide, right? That's the key here. Any pair can collide. If you have n keys, you have n choose 2 pairs, right? So what is the probability that two keys or one pair collide? 0.99. And given that you're using a completely uniform randomization, what is the probability? Let's ask the question the other way, right? What is the probability that there are no collisions? With I'm writing it very carefully, with n choose 2 pairs. Assuming that all the keys are like random, right? All the values, because it's a uniform hash function, it's completely randomized, which means each pair will be, everything is randomly hashed, right? So you can think of every pair, the probability of every pair having a collision, right, is the same. And the probability that any pair of keys have a collision is independent of each other, which means if you have one pair, the probability that they'll collide is 0.99. But if you have n choose 2 pairs, what is the probability? What is the probability that one pair don't collide? Probability that one pair don't collide is 0.99, which means what is the probability that n choose 2 pairs don't collide? It is 0.99 power n choose 2. That's why I said exponents. Humans are very, very bad with exponents. 0.99, when you raise it, again, n choose 2 based on what the value of n is, 0.99 raised to power 10, right? Okay, let's just use the calculator quickly, right? So if you just see, like 0.99 might seem like a small value, but if you say 0.99 raised to power 10, what would that be? That's 0.90, right? So humans, you might say 1% reduction, right? This is like 1% reduction, right? 0.99 is 1 minus 1%. But if you exponent it by 10, the value becomes very low. That is the key here. Okay, that is very, very important. Now let's go back to the math and work it out carefully. Okay, so the probability that there are no collisions with n choose 2 pairs is 0.99 power nc2. Now let me write it differently. What is the probability that there is a collision? What is the probability that there is a collision with n keys? And what does n keys mean? N keys basically means n choose 2 pairs. It's the same thing. 2 keys means 1 pair, n keys means n choose 2 pairs. This is nothing but 1 minus 0.99 into n choose 2. 0.99 power n choose 2. What is n choose 2? It's nothing but n into n minus 1 by 2. Right? Now, what are being asked? What is the minimum number of keys that must be present so the probability of collision exceeds 50%? So what is the value of n such that this is greater than 50%? That is the question here. You have to find the value of n such that this is greater than 50% or 0.5. Now, if you just use a calculator, plug in 50 here. If you actually plug in 50, you will get this probability, which is 1 minus 0.99 power 50 choose 2. You will get a value something like this. Again, you can use a Google calculator. 4 nines 7. This is what you will get. If you choose 51, you will get 0.99998. Which again, even if you choose 23, if you just plug in n equals to 23, you'll get a value of 0.92134, which means even if you have 23 keys, the probability that there will be a collision is 92%. Right? Now, you can solve this if you try various values of n. If you choose n equals to 13, right, you will get a probability of 0.54339. If you choose n equals to 12, you will get a probability of 48486, which means for a value of n equals to 13, this probability will be greater than 50%. At n equals to 12, this probability will be slightly less than 50%. So the question says, what is the minimum number of keys that must be present so the probability of collision exceeds 50%? And the answer is 13. Right? Again, this might feel very, very counterintuitive to many of you. I understand it. That's because we humans are very, very bad when we have this type of numbers, 0.910 type of numbers. We are bad with exponentiation. I think there is also a quotation saying that compound interest is one of the most complex concepts in the universe. Because this is like compounding, right? Most people don't realize the power of compounding. Okay, this is extremely powerful concept. Those of you who want to read more, there is a very nice blog, which I, one second, birthday paradox, okay, one second. Okay, so here it is. This is a very nice blog called Better Explained. I believe we have also touched upon this in our probability contents of the course, right? So again, experiments aren't intuitive. Very nice way of showing the same thing. Those of you who are still not convinced, play with this. They also have a small experiment that you can run here. The birthday paradox asks the same question. Imagine if there are if there are n people in a room, what is the chance that, what is the chance that 2 people have the same birthday, right? I mean, it's highly non-intuitive, but it's very beautiful probability theory. We have taken, again, please read this. It's I think Better Explained, Birthday Paradox. If you just Google search for it, you'll get it. I know some of you will not be convinced and we don't have time to go through this whole blog, but read it. It's a very nice blog, very intuitively explained with some nice calculators and things like that. Okay, the power of very nice blog. We also cover this in our probability, if I'm not wrong. Okay, so please go through that. Very nice question. I really love this question today because it is connecting the concepts of probability. Again, the probability that we used here is not some rocket science, right? We didn't use any Bayes theorem or anything. Okay, this is basic probability formulation. The probability that we used is probably something that you studied in 10th or 11th class. The key idea here is the exponentiation and the pairs concept. If you get that, this problem is easy to solve. And those of you who recognize that this is the birthday paradox, very good. You just have to connect that to hash functions and solve it. Okay, cool. Okay, somebody said, how did NC2 go into the power, right? Remember, I mean, if you have an event whose probability is 0.99 and you have another event completely independent of it whose probability is also 99, right? What is the probability that both events happen? Right? So simple probability, right? Very simple stuff there. So you just have to multiply 0.99 those many times. Okay. Again, please don't worry if this felt little like a bouncer to some of you. We will cover similar problems when we study probability in engineering math. We will solve lot of similar problems that will give you more confidence. But we wanted to form this very nice question related to hash functions. Again, something like this is there in a very similar problem is there in a standard textbook, right? The CLRS textbook in the exercise part, if I'm not wrong, because I remember solving something similar earlier. So don't worry if this felt little hard. This is by gate standard also, medium to hard. Okay, cool. Okay, next go to this question. Please read the question very carefully. I completely agree that the birthday paradox feels very unintuitive the first time. So please read the other blog that I pointed you to. Again, our team is also trying to answer some follow-up questions from the previous question. Again, for the previous question, some of you are assuming that the hash table has a fixed size. That is not mentioned in the question, right? So you can't assume that. Anyway, let's solve this question. I'm sorry to go back to the previous question. Please read the question very carefully here. Again, just to quickly point out, in the previous question, hash resolution can happen in many ways. We did not talk about linear probing or any form of probing for hash resolution. So I could just say, hey, I don't want to resolve any hashing. I'll just store all the values into a linked list, right? So it's better not to make that assumption that there is linear probing unless it is explicitly stated. The question was all about the collision and not about collision resolution. Anyway, let's focus on this question now. Again, let me give you a hint. Work out boundary cases. I think I've mentioned this in the previous live sessions also. Take a simple boundary case and work it out carefully, because most of these problems can be handled using boundary cases. By gate standard, I would rate this as a medium level problem. It could also be called slightly tricky if you don't read the question carefully. But if you know the basics, this is straightforward. This is a good 2-mark question actually. Okay, let's take some time because I've only seen a few answers. It's okay, take your time. Just work it out. The only hint is think of boundary cases. Okay, most of you got it right, which is good to know, because this is actually, if you just handle a couple of boundary cases, this is straightforward. I'll wait for a few more seconds and then go into the solution. Yes, the options are intentionally given to be confusing. That's why I said it's a little tricky. But most of you got it right, which is very good. So first and foremost, a balanced binary tree of unique values. Remember that what we are given here is already a balanced binary tree, right? It is given to the below function in C programming language to check whether it's AVL tree or not. If you're already given a balanced binary tree, for it to be an AVL tree, it just has to be a binary search tree. That's it, right? Every balanced binary tree need not be an AVL tree. It also has to satisfy the conditions of a binary search tree. So balanced binary search tree, which is a balanced binary tree, which is also a binary search tree, is AVL tree, right? So anyway, we are told that whatever is being given to us is a balanced binary tree. All that we have to check for is whether it's a binary search tree or not. That's all. Another way of thinking about it is, if you want to tackle this problem using boundary cases, imagine if I just take one node like this. Simple one node, right? This is null, this is null. Left child is null, right child is null. This is a balanced tree by definition. But whatever value you place here, it is also AVL tree. So you can't eliminate any options, or you can't think of these options based on this, because it won't help you much. Okay, so a slightly trickier case. Again, you can even think of this case where you have null. It will not help you to arrive at the solution so easily. A slightly better option that I can tell you is, so let's say I have 10 here. The left subchild is null. The right subchild is 15. Now this is balanced because the depth of the left subtree and the depth of the right subtree, they differ only by 1, right? And the root node is also less than all the elements in the right subtree, right? So this is also a binary search tree. So if you give this as the input to this function, it should return true, right? So let's assume we give the pointer to the root node. Okay, let's work out the code. Okay, so the interesting thing here is that you have a static pointer. That is a very interesting thing here. It's not a regular pointer, it's a static pointer. Okay, so you have previous pointing to null. Okay, so cool, that's simple. So right now what's happening? Previous is pointing to some null value. Now let's see the interesting part. Then it says if root. Okay, root is not null, so you'll go inside this. Now it says, so what will happen? It will first go to the left subchild. Okay, so now it will go again recursively. First it goes to the left subchild, then it checks something. This is what we have to find out. Then it updates the previous pointer. Then it goes checks the right subtree. Okay, that's how this whole logic itself is working. Now let's go to the left subtree. Okay, now what happens? This whole function will again be called. The previous will continue to point to null. It's not updated anywhere. But this root node is null, right? This is null, right? We are sending a pointer to this, which is null. So what happens? This whole thing will not execute. It will simply return true, right? It will simply return true. So till now, everything is working as expected. So now we come back to the actual function corresponding to the root node, right? So what did this return? This returned. So now we are back in the parent node here, right? Or the root node here. Previous is still pointing to null. Now what did this return? This returned true. So now what is it saying? It's saying not true. Then it won't go inside this. So cool. This code will not go. Next, what do we have to check here? Look at this. Now, what do we have to check here? Which means if you think about it, this true basically says that this left subtree is balanced. And anything which does, this is like an empty tree, right? Like an empty graph or an empty tree. So anyway, it returns true. Now all we have to care about is to compare this and this. That's what we have to focus on. We have to ensure that 10 is less than 15. That is the important thing that you have to check. Now let's plug in these values. Now if previous equals to null, look at this. In this option, if previous, right now what is there? Previous equals to null, right? Previous is pointing to null. If previous is pointing to null, can you compare the roots data to the previous data? Previous data makes no sense, right? Because previous is null. So this option you can completely rule out logically. Here also, if previous equals to null, how can you compare roots data with previous data? Previous data does not exist. So you can also eliminate this. So the only valid option here is if previous is not equals to null, but right now previous equals to null. Look at this, the previous is still null, right? So this condition will not work, this condition will also fail. So it will not return false, right? Again, I'm just going step by step. So we are now with respect to the root node. Then what happens? Previous becomes root. This is interesting. Now previous will now point to root node. Cool. Previous will now point to root node. After previous points to root node, we are calling this function recursively with the root node of the right subtree. Okay, now what happens here? Look at this. So when we go ahead and try to check for this, now we have to compare this 15 with 10, right? See, remember previous is pointing to this now, right? This is my current node. This is my root node now. Again, when I go recursively down, right? This will be my root node. This will be my previous node. I should always ensure that whenever previous is not equals to null, the root node, right? One second. One second. So the root node should be less than previous data. Just a second. What will the root node be? One second. I just want to be careful here. 1 second. So, okay, so 1 second. Let me just track back and be careful here. Just be careful because I'm just getting confused with what is root and what is not. Okay, so 10 is processed right now. When we are processing 10, okay, see, we are still processing 10. we go to root right. Okay, so just a second, right? 1 second. So root right, we go here. So we called this. So this becomes the root node now. So previous is pointing to this, right? Now next time when we recursively call with respect to this function, right? This is root, okay? Next, what happens here? Return this. So we go here, okay? We just have to be careful. Previous will point to the parent node. We just have to make sure that the previous is, why will 15 be the root? 15 will be the root. Yes, you're right. Again, I just want to do it carefully. I think, okay, let me just do it carefully to avoid a silly mistake here myself. Okay, root will point to 15, previous will point to this. So now we are calling this function. So we are going into the recursive function with this. Is root equals to null? Okay, let me just erase this to avoid confusion now for a little while. Okay, just a second. Okay, I just want to do it carefully. So now root is nothing but 15, previous is pointing to 10. Okay, we are here, we are running this code. Is root equals to null? No, it's not equals to null. What about the left tree? The left is pointing to null, the right is also pointing to null. So this will, again, this code will not execute. Now what do you have to check? Now look at what we have to check. We have to ensure that the previous data is less than the root data, right? Again, this is the check. Now the check will happen, right? We have to make sure if, okay, it says return false. Okay, that's another tricky thing. Okay, that's good. So it says return false. So when will we return false here? If the root, okay, so when will we return false? If these numbers are jumbled up, because this is perfectly all right. This will return false if 15 was here and 10 was here. Okay, so my answer is correct. Okay, I thought through correctly only. So for 10 and 15, what should happen? We should return true, not false, right? Which means what should this condition be? This condition should be the negation, or in other words, this condition would be that root data is less than previous data. Look at this. If root data, if this data, imagine if this was not 12, or let me change the color a little. Imagine if this was not 12, if this was 8, let's assume, okay? Then root data is less than previous data. Then we should return false. That makes sense. So C is the appropriate option and not A. Because it's returning false, not true. That is another tricky part of the question that I almost fell for. I solved this question earlier. Again, we have to see what it is returning, false or true. Okay, so C is the appropriate option because this condition will only be, it will return false if these numbers, see, in an AVL tree, this number should be less than this, right? That's what it should be. Again, we are also given that they are unique values. That's why there is this less than equal to here. Okay, that's the key idea otherwise. Okay, so C is the correct option. Okay, not A. Again, it gets a little confusing because of 2-3 things. One, it says it's already a balanced binary tree. So you have to recognize that for it to be an AVL tree, it just has to be a binary search tree, number one. Next, the static is a little confusing. These return values being false is slightly confusing. Okay, I think the false is the tricky part where all of us fall into the trap. I almost fell into it while solving it along with you. Okay, so you just have to be careful. So this is like a medium question, slightly tricky. It's not hard, it's just tricky. If you don't think about the what is pointing to what, because of recursion, you can easily get into tricky situations. Cool, so let's get into the fifth question now. Yes, naming sometimes intentionally the naming also can get very confusing. But I think this is okay here in terms of naming. Okay, so let me squeeze in the whole question here. Okay, so here is the question. So these first two columns represent option A, this represents option B, this represents option C, this represents option D. Again, somebody is asking about what if the root only has left child. You can work out that case also. It will also work in that case. It's just more tedious, that's it. This is like a simple, typical hash table problem in Gate. Again, this would be easy by Gate standard. Good. Most of you got it right. Good. This is a very simple problem. Simple linear probing, simple hash table. If you know what linear probing and how mod 10 hashing works, this is straightforward. Good. Most of you got it right. Okay, I'll go into the solution because this is fairly easy. This is like literally a 1 mark giveaway type of question. But these questions are also important in GATE. Please remember that in GATE, easy questions will be roughly about 50-55 marks. 50 to 55 marks are actually easy questions across all subjects. So if you score these perfectly, you just have to answer some of the medium questions or the easier amongst the medium questions to get into the top 100. Lot of people don't focus on the easy questions or they do silly mistakes there. Okay. So first we see 162. Okay. So mod 2. So 162 will go here. Obviously, that's a no-brainer. Okay. So 162 will go here. 2 is filled. 155. So 155 will go here. Okay. I'm just filling in the values here. Okay. So this is done. This is done. 432. 432 can't be filled here because again mod 10 2. Right? It can't be filled here. So linear probing will just place 432 here. Done. 212. Again, it'll get bucketed to this location because the last digit is 2. Mod 10, you get 2. It's full. Linear probing. So next one is also full. It'll try and place it here. So 212. Right? Then you have 72. 72 also will get hashed here. And then you start doing linear probing. Full. 72 will go here. Okay. Then you have 195. 195 will get bucketed to this location, but this is full, so 195 will go here. Linear probing, right? 430 will go to, location 0. That's it. So which is mapping here? A is mapping. Simple, straightforward question, right? Very simple, very easy to do it. Cool. Sounds good. So with that, we wrap up the questions for today. Let's tackle a few questions from the chat window. Okay, I'll try to answer as many as possible. So somebody had this question whether I should join IIT Delhi or should I drop a year. We would strongly recommend that you join IIT Delhi because dropping a year doesn't make so much sense. What if you don't get a good rank next year? Right? You're dropping a year unnecessarily. Go to IIT Delhi, work hard there, get a good rank and or study well there. You'll get good placements even at IIT Delhi. If I were a student with all the experience in retrospective, all the knowledge that I have, I would actually join IIT Delhi. I mean, I would do it personally. Cool. Okay, Satyajit says how to avoid silly mistakes. Again, oftentimes it's all about you didn't read the question carefully or you mixed up BFS, DFS. Happens to all of us. So make a note of all the silly mistakes you made and make sure you don't repeat that type of mistake. We often recommend our students to make a list of all the silly mistakes, make it part of your revision, okay? Because that will hurt you very badly and then you will say, hey, I will not repeat this mistake next time, okay? So that's the best way to avoid silly mistakes. It has worked very well for me personally. So one of the questions is, what about NITI Bombay after GATE? Jaina, I'm not very knowledgeable about NITI, so please shoot an email. One of our teammates who has studied about NITI and things like that, they can give you a better answer. I don't want to give you a non-comprehensive answer which I don't understand well. So I think so one of my teammates certainly, because they study all the top universities, their placements, their curriculum, etc. I did not study the NITI, what is happening at NITI, so I will not be able to comment on it. Vaishnav, I don't know when the result of IIT Hyderabad is going to come out, but I think they would have mentioned it in the examination, right? Roughly, at least roughly. This is very nice. Anvesh has a question which is, what if my objective is to do a PhD? Very nice question. So if your objective is to do a PhD, a couple of things that you should keep in mind is take slightly advanced courses at your graduate level. Try and choose a professor early on. That's what most of my friends who have gone on to do PhDs have done, which is choose an area. Try to choose an area early, do as many courses as possible in that area, try to work with a professor who works on the cutting edge of that area, try and publish 1 or 2 research papers. Most of my classmates or batchmates are 1 year, 2 years juniors. They graduate from the MTech program. They work for a year or so at one of the research labs, and they publish actively in that 1 year. So that will give them enough, and they try to publish in the top level conferences and journals, which will give them enough, and also their professors write them good recommendation letters because they've actually published research work that will get them into top universities like Stanford, Berkeley, CMU, etc. Most of my batchmates or friends who have done PhDs, this is the path that most of them have taken. Cool. That's a nice question. Anup says, how many questions should we do per subject? Again, it depends on the weightage of the subject itself also, right? So roughly speaking, we would say if you have solved about 2000 questions across all the subjects, I think, and if you have solved them diligently. So there is a video on our channel which is how to build the problem solving skills. Please check it out. If you solve 2,000 to 3,000 problems, I think if you solve them very diligently, very carefully, struggling through the process, building your problem solving skill across the whole gate, I think you're in a very good shape. Yes, so Rajan says my rank is 450. I'm joining IIT Bangalore. Yes, so I think it's a good takeaway, to be honest with you. IIT Bangalore is picking up well. Their curriculum is also slightly better than some of the older NITs also. So it's a good place. Make sure you're in the top 5% of class. Make sure you work hard towards it. Build the core skills that the industry needs. And there is nothing that's stopping you to getting into the top companies through IIT Bangalore. I mean, that's fairly doable. So can you suggest some source where we can practice questions other than PYQs? PYQ certainly is a good option. The other place that I see is standard textbooks. Take the first 10 problems in the exercises. They tend to be typically of the gate level. Good textbooks, right? Even if you take, let's say, CLRS, right? The Codman, Lizards and Rivest, Introduction to Algorithms. Don't go too deep because they tend to become slightly harder, slightly away from the gate standard. Solve the top 10 questions in the exercises. If you can do that, I think you're very, very well prepared for GATE, because we do use that actually. We do use that extensively to set our question papers, to get inspiration for various types of questions. Another good place is take top university assignments and examinations. Those are a nice place to get some very good questions. That's what I would recommend. Okay, cool. I think you should focus on getting your GATE first, and then getting into a company after your masters. You have 2 more years afterwards. So don't worry about it right now. First, get your fundamentals right. It's very easy to dream because it costs nothing, right? It doesn't cost effort, hard work, anything. It's easy to do it. But if you work hard for GATE, build a strong foundation, work hard during your masters, getting into any company anywhere is fairly doable. So this is from Arpon, who says, after watching the course videos, solving practice tests, should I also solve GATE PYQs or just move to practice tests in other course? Again, if you have time, solve PYQs, but we will anyway cover all the formats of questions that are there in PYQs in the test series, in the previous year test series and also this year test series. So you will not miss much in terms of the types of questions. If you have time, we strongly recommend that once you finish a subject, once you finish all the practice tests, try and solve the topic tests and subject tests corresponding to that subject from our previous year, from 2021 test series and 2022 test series. As a course enrolled student, you have access to that. Even after that PYQ should become fairly straightforward for you. But if you have time, please do that. I mean, nothing, more practice never hurts. Ayush says, how to motivate myself to work hard. I mean, it's like I can give you a pep talk, as they call it in sports, right? And you'll get motivated for 1 or 2 days. Then again, you'll slack. Motivation has to be very inherent. You have to have that long-term vision saying, hey, this is where I want to be 1 year or 3 years down the line, and I will put in consistent effort day in, day out. I think the inherent or implicit motivation is underrated. You have to see yourself, you have to work towards that, right? Any pep talk that I give you, any motivation that I give you will stay for a day or two. Beyond that, what will happen? You will again go back to, it's like physics, right? Everything goes back to an equilibrium that it is comfortable in. So only motivation which is implicit or inherent will work in the long term. Otherwise, it's all too short term pep talks. Cool. Again, another very nice suggestion from one of the students is, instead of thinking too much about motivation, probably you should think of habits. Again, we have a video on the same topic on our course videos, because who will motivate you every day? Even your implicit motivation is hard. Who motivates you to brush your teeth every day in the morning? It's a habit that you've formed over the years. Simple logic. What is your motivation to eat your breakfast or dinner at a specific time? You've just become habitual to it. What is the motivation to go out for a run in the morning or evenings? So I think more important than motivation is habits. Try to fix fixed slots and say, during this time, no cell phone, no social media, no distraction. I will study and finish this much work. I think that's what matters in the long run. Everything else is secondary. Cool. Somebody says, is it too late to crack GATE? Not at all, not at all. We have seen a lot of students in the previous years who actually start their preparation in July, even August and September. So as I often tell you, if you give good 6 months of effort for GATE, you can crack it. It's as simple as that. Actually, most people seriously prepare only for 6 months. They might prepare for 2 years, 3 years, but their serious effort, consistent, dedicated, serious effort is typically 6 to 7 months. So anybody who is serious about preparation, I think even if you start in September, you can crack it for Feb. It's possible. You just have to be very disciplined about it. That's it. Cool. Again, please don't misunderstand me. I'm not trying to ignore anyone. It's just that there is a flood of questions and I cannot answer every question in a public live session. That's, I think, understandable. Again, any question that I could not answer here, feel free to shoot us an email and one of our team members will try to answer you, right? We always have that backup plan. Cool. Again, somebody is asking about the course. Feel free to email us. Yes, it includes everything, everything that's needed for GATE. Okay. Sounds good, folks. I think we have had a good session today. Very nice problems. I agree that the birthday paradox problem was slightly trickier. If you could not solve it, that's okay. We will solve many such problems when we study probability. You'll get much more comfortable then. And thank you very much. See you in the coming days. Bye-bye.